day, everyone. I am SKZ, your instructor for today. In this tutorial, we'll learn how to determine the radius, center, and interval of convergence of a power series using the ratio test.
Before we proceed to the computation or the examples of the power series convergence, let us know the important or why power series convergence is important. The convergence of power series is important for several reasons. First, at defining functions. Many important mathematical functions such as exponential, logarithmic, and trigonometric functions can be expressed as power series. Second, in approximation. Power series provide polynomial approximations to functions, which are crucial in numerical methods and solving differential equations. Lastly, applications in physics and engineering. Power series are used to model real-world phenomena, solve physical equations, and analyze systems in fields like electronics. Now, you can see the meaning of the power series, the interval of convergence, and the radius of convergence, which are used in power series, and the radius and interval of convergence of the power series. In the figure 2, the table shows the possible ratio test results of the x values, the radius, and the interval of convergence. So, let's start to solve. So, let's start with number 1. Number 1 given is the summation of x raised to n over n factorial as n approaches to infinity. So here we have the condition as limit of n approaches to infinity, u sub n plus 1 over u sub r will be less than to 1. So the un plus 1 here in the given is the x n plus 1 over n plus 1 factorial. And our u sub n is equal to the given. So the given here is x raised to n over n factorial. So now let us substitute the limit of n as approaches to infinity, our un plus 1 and the u sub n. So x raised to n plus 1 over n plus 1 factorial divided by, it will divided by the u sub n or our given, the x raised to n over n factorial. Next, the limit of n as approaches to infinity will be the simplification of the simplification of the above equation. So it will be x raised to n times x raised to 1 over n plus 1 and n factorial, as we use the ratio test in the power of convergence or the power series of convergence. We will reciprocate the u sub n and it will be n factorial over x raised to n. So now we will canceling the same terms that will be cancelled in the given. So simplify it and it will become the limit of n as n approaches to infinity will be 1 over n plus 1 times the value of the x. Now we will substitute the infinity to the n, so it will become the 0 times the value of x, which will be equal to the 0. Since 0 is less than 1, the number 1 given is converges, or it will be converging. So in this given, also as you can see at the table or the figure number 1 in the introduction, the radius will be infinity and the interval of the convergence will be negative infinity to positive infinity. And the center is the 0. Now let us proceed to the next example. And our given will be the summation of x minus 1 raised to n over 3 raised to n as n approaches to infinity. Now, you can try it on your own, as you can see the example number 1 earlier. And yes, we will be having the condition a sub n plus u, or the u sub n plus 1. It will be equal to x minus 1 raised to n plus 1 all over 3 raised to n plus 1. And the next one is the a sub n, or the u sub n, and it will be equal to the given problem, which is x minus 1 raised to n over 3 raised to n. And now we will be having the limit of n as approaches to infinity, and we will be substituting the a sub n plus u and a sub n, and it will be equal to a sub n plus u over the a sub n. So we have the x minus 1 raised to n plus 1 over 3 raised to n plus 1 over the a sub n, which is the x minus 1 raised to n over 2, or over 3 raised to n rather. And now we will simplify our given. So as x minus 1 raised to n plus 1 over 3 raised to n plus 1, it will be equal to the x minus 1 raised to n times the quantity of x minus 1 over the 3 times n, or the 3 raised to n times 3, and it will be over to the a sub n, which is the x minus 1 raised to n over 3 raised to n. Now we will be having the limit of n as approaches to infinity, x minus 1 raised to n times the quantity of x minus 1 over 3 raised to n times 3. which is the result of simplifying the last given, and it will be multiplied to the reciprocal of our a sub n, which is 3 raised to n over x minus 1 raised to n. And now we will be canceling the same term, which is x minus 1 raised to n and 3 raised to n. Now we will be having the values of x minus 1 over 3, which will be less than to 1. And we will be canceling the over 3, so we have the 3 in this side. And it will give us the x minus 1 less than to 3. Since we can see that our radius is equal to 3, we will be having the x minus 1 is less than 3 but greater than to negative 3, and we will be adding the plus 1 to the both side, and it will give us the x is less than 4 but greater than to negative 2, and it will result to the interval of convergence, the negative 2 and the 4. Since our r is greater than or equal to 1, our given will be diverging or diverges. Now, we will check if our equation or our given is correct with having the radius of 3 and the result will be equal to 1. So let us substitute the interval of negative 2 which will result to negative 2 minus 1 raised to n over 3 raised to n, and it will be equal to negative 3 raised to n over 3. Next one is the interval of convergence, which is the 4, and it will be substituted by the given. So we will having 4 minus 1 raised to n over 3 raised to n, and it results also to 3 raised to n over 3 that give us the radius is greater than or equal to 1. So our result is negative 1 raised to n and 1 raised to n, which is also the 1, and it will give us the radius of 3. The interval is negative 2 and 4, and our center is negative 1.
A power series is a mathematical tool used to represent functions as infinite sums of terms involving powers of a variables. Its convergence is crucial because it determines the range where the series accurately represents the functions. This concept has practical applications in physics, engineering, and numerical computation, where power series are used to solve differential equations, approximate functions, and model real-world understanding the radius of the convergence ensures that these applications remain valid and reliable, making power series an indispensable part of the modern